Here's an example in which we are raising a complex number in polar form to a power. So we have this complex number in polar form raised to the third power, and we want to give the answer here in polar form. Okay, well, how do we do it? Well, it's in our notes, the notes that I put on the top of Module 5 right here. This is the notes, Chapter 10.3, 4, and 5, complex numbers in polar form. Come all the way down here to number 10. And that's what we want, power of complex numbers in polar form. So I put it right here, copied it for us right here, so we can look at it. Well, power of complex number in polar form. How do we do it? To raise the power in front to the n, multiply the angle by n. That's simply it. In other words, if you have this complex number to the nth power, you just raise the number in front to the n, and you multiply the powers, right? That n multiplied both those angles. So it became the power of the number in the front, and it times the angles. Now, why is that? Well, it comes from the fact that, remember what a power is? A power is multiplying. If I go 3 to the 4th, that means 3 times 3 times 3 times 3, 4 times. You know that, right? Power means repeated multiplication. Well, therefore, nth power means this thing multiplied by itself n times, doesn't it? I'll say it means, this means, or it equals, r cos theta plus I sine theta times another r cos theta plus I sine theta times, etc. And there are how many of these? N of these, right? Isn't that what a power means? Raising something to the nth power means multiplying it by itself n times. Okay, great, so what? Well, up here we learned that when you multiply two complex numbers in polar form, what do? You multiply the numbers in the front, add the angles, don't you? You multiply the numbers in the front, add the angles. So therefore, the way to multiply all these together, n of them, because it's nth power, is to multiply r times r times r, etc. So we're going to have r times r times r, didn't make that very clean, etc. N of those, right? N of these, which is what? R to the n, right? Okay, yeah, but what about the angles? Well, what are you going to do with the angles? What does the adding rule say? The multiplying. Multiplying complex numbers, you add the angles, don't you? You take this angle and that angle and you add them. So theta plus theta plus theta, etc. How many of those? N, right? Nth power, n of these. So what is theta plus theta plus theta n times? It's n theta. Do you get it? This is r to the n cosine of n theta, right? Theta added to itself n times. Like if I added 5 to itself 10 times, it's 5 times 10, right? So if you add theta to itself n times, it's theta times n, or n times theta, and the other angle is exactly the same. There's the formula. I just derived the formula. This is de Moivre's, the French mathematician's formula that he came up with. That basically it's really simple. If you want to take a complex number to the nth power, you just do the power on the front and you just multiply the two angles by that power. That just comes straight from the multiplying rule because powers are just repeated multiplying. All right, so let's do it. So we just take the 3 power and we just put it right on the 2. So 2 to the third, it's going to be 8 in a minute, times the cosine. And what do we do with the 3 here? We multiply the angles. 158 times 3 plus I sine of the exact same thing. Okay, and so what's going to happen at that point? Well, we're going to need to change this to an 8. And this will be cosine. 3 times 158, I'm going to use my calculator. I'm getting 460 474 degrees plus I sine of 474. There we go. But the angle has to be between 0 and 360. So you know what to do. We've done this before. Just subtract 360. You can always add or subtract 360. It doesn't change anything. Same position when you're done. So it'll be 8 cosine of whatever that is, 114 plus I sine of 114 degrees. So what did we do there? We raised a complex number to the third power, which meant we just powered the front number and multiplied the two angles by 3. Got 474, and then had to subtract 360 because we always want our answers between 0 and 360. So that's how you raise a complex number in polar form to a given power. So that's pretty convenient. See how we could, imagine if we didn't have that rule. You'd have to write 3 of these, right? You'd have to write this whole thing 3 times and like FOIL them all out. That'd be terrible. And then what if this was like the 10th power? You're going to write 10 of these and FOIL them all out? It'd be forever. But with this special rule, de Moivre came up with, a French mathematician, you could just take that power and just do it on the front, 2 to the 10th, and then just multiply the angles. In fact, I can do it right now. It'd be, just add a 0 to the back, 1580, and then just subtract a bunch of 360s to get it under 360. It's that quick and easy to multiply 10 complex numbers together when they're in polar form. Do you see the beauty and the power of polar form? This is why math and science people like polar form, even though it might feel a little painful to you right now, I imagine. If you go on in math and science, polar form is very convenient. You can start to see some of the nice things, powerful things we can do easily with de Moivre's theorem here. Easy to multiply 10th power, a big complex number in polar form. There we go.